Okay, guys, so 6.2b, example 1, bless you. We have 5 to the 4th power times 125 to the power of x.
What?
Right. Previously, when we were multiplying powers, there was one overall rule that we had to follow. Does anybody remember what it was? No negatives in the exponent. That was one of them. It had to do with the bases. Do you guys remember? I keep the base, but the base has to be the same. So we need the same base. So let's write that must have same base. So we have to have the same base here. Obviously, I don't. So I need to figure out how I can write 125 as a base of 5. How could I write 125 as a base of 5? 125 is 5 times 25, which is 5 times 5. So it is the same as 5 to the 3rd power. Now the reason why I put 5 to the 3rd power in parentheses is because it is the exact same as 125. All I did was rewrite 125 as 5 to the 3rd power. Is everybody okay with that? And it's all being raised to the power of x. So all I did first was rewrite it as a base of 5. Now, when I raise a power to a power, what do I do with the exponents? Do I add them or multiply them? A power to a power? Multiply. So this is 5 to the 4th times 5 to the 3x. Okay, so now we can go ahead and multiply these things. We keep the base of 5, and what do I do with those exponents? I add them. So this is 3x plus 4. So that's my answer. We can't add them because it's a 3x and a 4, so they're not like terms, so we have to leave them separated. This is all going into something else later on. First, before we can move on to the next concept, we have to master this idea of just leaving our exponents in terms of expressions. So eventually, we will be doing stuff with this, but right now, we're just putting them together. Okay? Example 2. 2 to the 1/4 times 2 to the 2/3. Can I go straight into multiplying these guys? Do I have the same base? Yeah. So this is a base of 2. And what do I do with the exponents? Add them. So this is 1/4 plus 2/3 in the exponent. Now we want to simplify this as much as possible. So I heard a couple of you saying it. We need to get a common denominator. What would the common denominator be? 12. So 1/4. What do I have to multiply to get 12? 3. So we multiply top and bottom by 12. What about 2/3? What do I multiply by? 4. So times 4 times 4. So I'm still writing it all out because I want to show all my steps. That's going to give me 2 to the 3/12 plus 8/12. So in my exponent, I have 3/12 plus 8/12. So that's going to give me 2 to the 11/12. And you can leave your answer like that as well. So all we're doing right now is simplifying. Example 3. 4 to the 1/3 times 8 to the 2/3. Okay, here's what I see a lot of. Okay, so we want a base of 4. So 8 is 4 to the 2nd. So I can change 8 to 4 to the 2nd. True or false?
No, false.
False. What's 4 to the 2nd?
16.
16, not 8. Can I write 8 as a base 4? No, but I can write it as a 2. Can I write 4 as a 2? Yeah. 4 is 2 times 2. So that is, in parentheses, 2 to the second to the 1/3. And 8 is 2 to the third. So times, in parentheses, 2 to the third, all of that to the 2/3. So before we can combine the bases, we have to, with our exponents here, a power to a power means that I do what with the exponents? Good, multiply. So this is 2 over 1 times 1/3. So that's 2 to the 2/3 times 2. 3 over 1 times 2 over 3. Please do not cross reduce yet, because we're going to end up needing common denominators. So this is going to be 6 over 3. Okay, now what do I do with those exponents? We do what? We add them together. Good. So that's 2 to the 2/3 plus 6/3, which gives me 2 to the 8 over 3. And it's okay to leave our exponent as an improper fraction. It actually makes more sense. We wouldn't want it to be 2 to the 2 2/3. That's really, really difficult to write. So just leave it as 8 over 3. All right, ladies and gentlemen. Okay, so example 4, remember roots and exponents are basically the same thing. A root can be rewritten, Tarada, as an exponent to a fraction. So let's apply this exact same thing to roots. The 4th root of 10 plus 7 times the 4th root of 10. So the way that I look at this is that roots work like terms. So the roots have to be exactly the same on the inside and the type of root that we're taking in order for us to be able to combine them. So if I have a 4th root of 10 and a 4th root of 10, are these considered like terms?
Yes.
Yes. So all I have to do, just like when I'm adding x's or y's or z's, all I have to do is add the coefficients together. So what is the coefficient of this guy?
1.
A 1. So if I have 1 4th root of 10 plus 7 4th root of 10, what would my answer come out to? 8 4th root 10. Now because we're adding, nothing with the 4th root of 10 changes. It's like your x. When I add 3x and 2x, it just gives me 5x. I don't multiply the x's or anything. Same thing here. Okay, so the root does not change. The only thing I want you to make sure that you do on all of these problems is double check that you can't simplify anymore. How does 10 break down? 5 and 2. Can I pull a 4th root out of either of those? No. So this would be our answer. Okay, so you need to make sure that you check that you can't simplify anymore. I am going to show you an example of one that looks like that. All right, example 5. We have cube root of 54 minus 5 cube root of 54. All right, are these roots the same? I have a cube root 54 and a cube root 54. So we can just combine the coefficients. So what is 2 cube root 54 minus 5 cube root 54? Negative 3 cube root 54. Now remember, please make sure that that cube root is attached to the root and not attached to the 3 out here. Okay? I've seen it so many times, and you guys write it, and I know that you know what you're doing, and then you think that it's a 3 cubed, and you write it out as negative 27. Okay, so just make sure that you are making sure that that 3 is attached to the root. It's not attached to the 3. Okay, so this would be my answer, except I can break down cube root of 54, right?
9 and 6.
Yeah, that's 9 and 6, and 9 breaks down to 3 and 3, and 6 is 3 and 2. So let's rewrite this whole thing first. This is negative 3 times the cube root
That's 2.
Now, how do we want to write this? This is called prime factorization, meaning that I take the number and break it down into as many prime numbers as I possibly can. So as small as you can break it down. And then we rewrite the number in terms of those primes. So this would be 2 times 3 to the third power. So 54 is the same as 2 times 3 to the third. Is everybody okay with that? The reason we write it this way is because it makes it really easy for us to see what I can and can't pull out. So looking at this cube root of 2 times 3 to the third, is it obvious what I can pull out now? What can I take out? That 3. That 3 to the third comes out and becomes negative 3 times 3. Cube root stays because what's left inside? The 2. We couldn't pull it out. So it stays a cube root. That cube root never changes. But I have to leave the 2 inside because I can't take the cube root of 2. So this simplifies finally to negative 9 cube root 2. Okay, so taking this idea now, and let's look at something a little more complicated. Example 6, negative 9x squared times the square root of 25x to the 5th plus 3 square root 49x to the 9th. Okay, now obviously I can't add these together right away, right? The roots are definitely not the same. So what we have to do is simplify as much as we can first and see if they simplify down to the same. So this is going to give me negative 9x squared, what's on the outside, times whatever I can pull out. Of 25x to the 5th, this is a square root, what can I pull out? Of 5. And how many x's? 2. That's going to come out as x to the second. And what's left inside that square root? An x. How do we get this? Remember, if I have a square root, the index is what? What's that little number, even though we don't have to write it? It's a 2. So what we can do is we can divide the exponent by our index. 2 goes into 5 2 times. And what's the remainder? 1. So that's what stays on the inside. Remember that? So what about this guy? 3 times, what can I pull out of square root 49? X to the 9th. 7x to the third. Remember, this is a 2. So 2 goes into 9 how many times? 4. Square root of what's left over? What's the remainder? 1x. Okay, because if you guys think about it, if it's x to the 9th, how many x's are actually inside? 9, right? Because this is x times x times x times x. So if I pull out 4 pairs, that's 8 that I pulled out. 1 is left. Okay, so let's simplify a little bit more. Negative 9x squared times 5x squared. That gives me negative 45x to the 4th. Good. Root x. Plus 21x to the 4th, root x. Now do I have like terms? Yeah. I have an x to the 4th root x and an x to the 4th root x. So that's going to give me negative 24. And then x to the 4th root x stays exactly the same because all we're doing is combining like terms. We're not doing anything else. So we just combine them and it stays the same. So that's our answer. Not too bad? Okay, last one then. Example 7. Okay, example 7. 5th root of 486 plus the 5th root of 64.
No, what?
These are obviously not like terms, right? Yes? Okay, so how can we break it down? How does 486 break down? 2 and what?
240.
243. 243 is 2 and 2 and 2 gives me 243.
There's a 2 in there. I know
There is a 2 in there. 2 and 81.
I thought it was 3.
Or 3 and 81. This is what I get for listening to Karina. 81 is 9 and 9, and that is 3 and 3 and 3 and 3. So this is the fifth root of 2 times 1, 2, 3, 4, 5, 3 to the 5th. When we're doing prime factorization, guys, so when I'm writing it all out in terms of multiplication, we always like to put the numbers from smallest to biggest. So that's why I've always been putting the 2 first, and then 3. And this is a 3 to the 5th, not a 3 to the 6th. Okay, plus 5th root. How can we break down 64? 8 and 8. That's 4 and 2 and 4 and 2. And 4 is 2 and 2. So how many 2's are there? 4, 5, 6. So this is 2 to the 6th.
Oh, I thought that was a 3.
Okay, so let's simplify some more. 5th root of 2 times 3 to the 5th. How does that simplify?
3 to the second?
3 root, 5th root of 2. That's 5th. It's not a square root, it's a 5th root. So make sure that you're always writing that 5 there. So because this is a 3 to the 5th, I can just pull it straight out. And then this one makes it a little more complicated. I have the 5th root of 2 to the 6th. How many 2's can I pull out?
1.
5, and then it becomes 1, right? So a 2 on the outside. And is there any left on the inside? Yeah, how many? 1. So now do I have like terms? Yep. So that's going to give me 5 times the 5th root of 2. And just because we're just combining like terms, so adding or subtracting, that's why that root never changes. You just add or subtract the coefficients.